Let us now discuss about one-way ANOVA. Here is the case study. A marketing organization outsources their back office operations to 3 different suppliers. The contracts are up for renewal and the chief marketing officer wants to determine whether they should renew contracts with all suppliers or any specific supplier. And the chief marketing officer wants to renew the contract of supplier with the least transaction time. CMO will renew all contracts if the performance of all suppliers is similar. Alright. So here, step 1. What is the underlying business problem? The underlying business problem here is, should the CMO renew contract? Should the chief marketing officer renew contract of all suppliers or not? Or should he renew contract for a specific supplier? That's a business problem here. Now we need to get into data. We need to get into data and identify what is Y and what is X. Not from business perspective, but now you need to get into data. If you get into data, you'll understand that transaction time is what you need to measure and compare for the 3 different suppliers. So you have supplier A, supplier B and supplier C. Now the third step is extremely simple. You need to find out the data type. Transaction time is continuous because you can represent time in decimal format. The 3 suppliers is discrete. So what test are we going to employ if Y is continuous and X is discrete in greater than 2 categories? So if Y is continuous and X is discrete in more than 2 categories, then we need to perform ANOVA, analysis of variance one way. And whenever Y is continuous and X is discrete, we always have to resort to this flowchart. So we are comparing more than 2 population samples with each other. So here we are trying to compare transaction time of supplier A with transaction time of supplier B with transaction time of supplier C. Ultimately, to determine on what test we need to perform, there are some intermediate tests. The first test here is normality test. What does your null hypothesis say when it comes to normality test? Data are normal. And what does your alternate hypothesis say? Data are not normal. This is how you need to write null and alternate hypothesis, right? So let me write it down here. So we have the ultimate business problem on whose contract should CMO renew. As part of this, we are performing normality test. And null hypothesis of normality test says data are normal. Alternate hypothesis says data are not normal. If data are not normal, you need to take an action and transform the data. That is why it is not normal. Now, here is the transaction time pertaining to each and every supplier, and you have 3 suppliers, A, B, and C. We need to first look at the normality test. So stat, basic statistics, normality test. We need to first select supplier A transaction time. Let us check whether it follows normal distribution or not. By the look, I know that all the data points are falling along the line, so data follows normal distribution. But statistically, how do we prove that? By looking at the p-value. Anderson-Darling test p-value is 0.941. So if the p-value is 0.941, this is greater than 0.05, which implies p high, null fly. That means you're going to accept null hypothesis. What does null hypothesis say? Data are normal. And this is for supplier A. Let us do this for supplier B also. Let me choose this data set. Here is supplier B, stat, basic statistics, normality test. I select supplier B, click on OK. By the look of this, I feel the data are normal, but we also need to look into the corresponding p-value. P-value is 0.448. Anderson-Darling test p-value is 0.448. So p-value is 0.448, which is greater than 0.05. What does that imply? P high, null fly, which implies you're going to accept null hypothesis. What does null hypothesis say? Data are normal. Now let me do this test for supplier C also. So I'll go back to this worksheet. I go to stat, basic statistics, normality test. This time I'm going to select supplier C and click on OK. By looking at this, you know once again that all these data points are falling along this red line. Hence data follows normal distribution. But statistically, if you want to look at this, then look at the p-value. P-value is 0.433. Which is greater than 0.05, which implies p high, null fly, which implies you accept null hypothesis. What does your null hypothesis say? Data are normal. If data are normal, yes, if data are normal, you need to proceed with variance test. What if data were not normal? You perform Kruskal-Wallis test. We'll come to that later on. These are non-parametric tests. But if data are normal, you proceed with variance test.